Hi, I'm Andrew Freed from IBM Watson, and I'd like to talk with you about developing natural language processing using machine learning. In my previous video, I showed you how to do natural language processing using rules. Now, rules-based language processing uses programmers who review a block of text and try to extract patterns out of that text that help us figure out what the meaning is. In machine learning natural language processing, by contrast, we let the machine figure out the patterns for us. The way we do this is we provide the machine with a series of documents and a series of things that we want to extract from within that document, and we let it reverse engineer the patterns for us. So let's take a look at how this might work. Again, to set up the problem, I'm trying to extract programming languages from a block of text. And here I've got the Wikipedia article on programming languages. I'm going to take this article and feed it into Watson Knowledge Studio. I've already created a project in Watson Knowledge Studio, and the first part of my project is to define what things am I trying to extract from the text at all. And I'm trying to extract one thing. I'm trying to extract programming languages. So I've created an entry for that in my type system. The next thing I need to do is upload a series of documents to train the system. I took that Wikipedia article and I split it into several chunks, about 13 chunks. Now, the Watson Knowledge Studio documentation suggests you split a document into chunks of 2,000 words. However, I split my document into 500-word chunks because it was actually only a single document. I needed as many different chunks as I could get. Also, as a human annotator, it's easier to work with more smaller documents since you get a little bit of a break in between documents. After I uploaded these documents, it's time to train the system. Now I've actually already done this, but let me show you what I would have done in that system. So I've got an annotation task, and I can open that annotation task, and it's showing me all the different segments of that article that I uploaded. So let's take a look at one. I had gone through this article, and every time I saw that there was a programming language, I selected my programming language type from the side, and I selected the span of text that I wanted to cover. Here I wanted to cover C, so I had highlighted that one. I highlighted the programming language Perl, and so on and so forth throughout the rest of the document. I did this for all 13 document segments, and I submitted this to the machine learning model. Now again, I've already run this model, but let me show you how I set it up. So the first thing I did in setting it up was I told the system how it could use these documents, how it could split them up. So I said, I'm going to go with the recommendations here and split the documents into 3 sets. I have a training set, a test set, and a blind set. What that means is the system is going to learn what patterns I used in the training set. It's going to train based on that training set. And then it's going to evaluate its performance on the test set and the blind set. The special thing about the blind set is that it's not actually going to show me exactly where it went wrong in the blind set so that I'm not biased. But we'll get a chance to review the test set in just a second. We can also see that the system, after it runs, it gives us a little bit of performance indication. It says that overall its accuracy is about 53%. That's derived by 2 measures, the precision and the recall. So this is actually a pretty surprising result. I think it's because the model is very conservative, but 100% precision is more or less unheard of. I think this is actually an artifact of using such a small training set. But we also see the recall is pretty low. And again, I think that means the model is not very confident. It hasn't seen a lot of training data. It doesn't know when it should surface programming language out of the text. So let's take a look at what the model actually did. So here I'm looking at the evaluation of my model, and it says for the test set, I have a chance to view the decoding results. So these are the 3 documents from my test set, and I can open up one of them and see what it did. And as we open it up, we see, hey, there's some yellow highlights. This is good. That means the model detected some programming languages. I happen to know Perl and JavaScript. Those are definitely correct. Here we see JavaScript again. And if you remember from my rules-based video, I had created a rule that said you could only detect languages in lines that had the word language. So you can see here that the machine learning didn't need that. The word language never applies in this sentence. But it still figured out from the context that JavaScript is a programming language. And as I scroll on, I can see that it found several more instances of programming languages. But towards the bottom, I can see the model also made a mistake. It correctly identified Java and Smalltalk, but it definitely missed Scheme. Scheme was something I provided in my training documents. And we can open up some of these other documents, and we can see it's also made a couple mistakes. It should have found BASIC. I believe there are a couple other languages it missed. It missed VBScript and MATLAB, for instance. And again, this is because the model didn't have very much training data. But I wanted to show you how you can quickly get started with a model using machine learning. And in a future video, I'll show you how to improve this model by adding more varieties of training data.